They're all engineered for a specific purpose with a specific back pressure, and you really need to know if your fan is the right fan. And the way that you can figure that out is by finding out what kind of airflow it's giving for you during your drying events. Ultimately, you want to have, as we've said 100 times, you want 1 to 1.5 CFM per bushel is where you want to be, and you're going to get good, repeatable, efficient drying at those numbers. So I'm just going to walk through all the different types of fans and just discuss their sort of their merits. The fan mechanism for a low speed centrifugal is just your standard centrifugal water wheel type mechanism. It basically looks like this. The electric motor is on the back side here. So with these types of fans, you get no benefit from the heat from the fan, cooling the fan. Basically, all the air inlet comes independent. So you have a very slight loss of efficiency. It's relatively insignificant. These fans are designed to provide a high airflow against a low static pressure. Here's the fan curve plot. I've just got a standard airflow axis here, and we're maxing out at 16,000 CFM. I'll also mention that these are all the fans that I'm going to be looking at on this plot are 10 horse, and they're all grain guard fans. The curves, I just got them off the internet, off the grain guard site. But you can see here that at 7 inches of water, this curve has deadheaded. So that's the maximum amount of back pressure that this fan can see, and it is specifically designed for low back pressure applications. So that would be peas, corn, soybeans, and basically it can move lots of air when you have very low restriction. But even with that, you really need to have a monitor your back pressure so that you know, because the danger with operating blind is that when you get close to this deadhead, your airflow drops off extreme. So you will literally get to no airflow if you are very much higher than this 7 inches of water. The axial fan is the second fan on the list. This is probably the most common fan. It was the original fan that was brought into agriculture. It has a unique airplane propeller look, so you can recognize it anytime you see an axial fan. The motor is right in the airstream, so it actually does conserve all the heat from the electric motor that the electric motor produces. It is again designed for high airflow against low static pressure. And here is a 10 horse curve on that same plot. You can see it peaks out similarly, a little bit less, but it deadheads at the same 7 inches of water column. But really what jumps out at you is you can see that at every data point on this, when you compare these two fans, the axial fan has lower performance than the low speed centrifugal. So it really, to me, it jumps out that there really isn't a lot of benefit to buying an axial fan, and I think the main reason so many axial fans are out there, number one, is they were the first on the market, so axial fans were very common, and secondly is they're typically the lowest priced fan. But that's where buying based on horsepower is a huge mistake. You really have to look at these curves. You really have to understand your application. The next fan is an inline centrifugal. Again, the fan mechanism is the water wheel type centrifugal fan. It is an inline fan where the motor is in the airstream again. So again, we're conserving all the energy from both from compressing the air and the waste heat from the fan are being utilized. So it's basically 100% efficient. This design provides airflow against the higher static pressures. When I say higher, it peaks out around 12 inches of water column. So you do get a significant bump here, but you also see that there's a significant reduction in the maximum airflow. So at 2 inches, you're only putting out not even 8,000 CFM. where the axial and the low speed are putting out 12 to 14,000 CFM. But ultimately, the inline centrifugal is a good fan for in-bin drying because it gives you a broader range of discharge pressures where it can move good air volumes. The high-speed centrifugal is probably one of the most popular fans in use. Fan mechanism is again the water wheel type. It has the look of some would say a snail look to it, and also some farmers refer to it as a Keogh fan, and that's because Keogh builds a fan that is a high-speed centrifugal. Again, this fan has the electric motor outside of the airflow stream, so you do lose the efficiency as far as not gaining that heat from the actual cooling of the fan. It is very a low amount of heat, but it is a small benefit. This fan is designed to provide airflow against high static pressures, similar to the inline centrifugal. Here I overlay a 10 horse high-speed centrifugal right below the inline centrifugal curve here, you can see. And what sort of jumps out is that the inline centrifugal is the better choice up until about 9 inches of water column. But then when you have higher static pressures, you go up to the 11 inches, 12 inches, the high-speed centrifugal is able to move more air. And that's a big reason why I think the salespeople have in the past really pushed the high-speed centrifugal fan, and that really has become the kind of the standard or most popular fan in many instances on farms. And the reason for that is that it moves the most air against the highest static. So if you are filling your bins and you want to get as much airflow as possible, the high-speed centrifugal fan is your best option. But if you are actually filling your bins consciously and trying to get as much airflow as possible, I know with our operation we typically are in the 6 to 7 inches. So for us, inline centrifugal fan is the most efficient fan. The last fan, and this is sort of a premium fan, is the inline centrifugal turbo. The turbo has the similar water wheel mechanism. The difference here is that it has a slight taper to the body of the fan. So the inlet is slightly larger than the discharge, and with that, it's supposed to bring better performance. Whoops, jumped ahead again. Again, this fan is to provide airflow against a high static pressure. Here, because those fans, the turbos only come in a maximum 7 horse. So I've done a comparative plot here at 5 horse fans. This blue is our high-speed centrifugal 5 horse. Here is the inline centrifugal 5 horse. Again, slightly higher airflows at the 0 to about 7 inches, and then above 7 inches, the high-speed centrifugal gives you better airflow. And then here is your turbo fan, which based on the manufacturer's numbers, it shows that it gives better airflow on almost all points except at the very, very high static pressures. So I mean, based on these numbers, it says that is the most efficient option. It comes at a higher price, and I certainly wouldn't say to go out and purchase, just turbo fans. I would really recommend that you get the instrumentation and you get your dashboard for your drying bins, and you see exactly where the best place to operate based on your aeration air delivery system, and see what your cost per point is. Find out how well is your system performing with the existing fans, and optimize with the existing fans. And at some point you might want to test a turbo, see if it justifies the cost. But again, you have to take manufacturer numbers are directionally correct, but I like to be able to actually use real data on farm to make your decisions.